In this episode of Spaceflight News, we have prepared another 3 topics from the field of space exploration. We will commence with the departure of a Russian cargo spacecraft from the International Space Station. In the second topic, we will examine the launch of another batch of Starlink communications satellites from SpaceX. Lastly, we will conclude with a stunning view of a galaxy captured by the legendary Hubble telescope. At 7:55 Universal Time on November 29th, the Russian Progress MS-23 cargo spacecraft undocked from the International Space Station. Having been docked to the Poisk module since May 24th, the spacecraft had delivered approximately 2.5 tons of supplies, propellants, and scientific experiments, thus remaining attached to the station for a period of 188 days and 15 hours. The pressurized interior of the International Space Station is limited, thus necessitating regular disposal of superfluous items and trash. Progress spacecraft transports supplies to the space station and return laden with these items and trash. This was also the case with Progress MS-23. At first glance, Progress cargo spacecraft bear a striking resemblance to manned Soyuz spacecraft. However, they differ in their internal layout and, most notably, lack a heat shield and other systems for landing, such as parachutes. Consequently, Progress ships invariably incinerate in the atmosphere. For instance, Progress MS-23 vanished over the Pacific Ocean less than 4 hours after departing the station. The docking port on the Poisk module will not remain vacant for long. As early as December 1st, a Progress MS-25 cargo ship is slated to launch from the Baikonur Cosmodrome and dock there. We will likely address this topic in the next episode. On the 28th of November at 4:20 Universal Time, 9 Merlin rocket engines ignited, propelling the Falcon 9 launch vehicle from SLC-40 at Cape Canaveral, Florida, into the night sky.
And liftoff. Go Falcon, go Starlink. Vehicles pitching downrange. Engine chamber pressure is nominal.
The Falcon 9 upper stage delivered 23 Starlink satellites to an altitude of approximately 290 kilometers, from which they will autonomously transit to an operational orbit of 530 kilometers. Starlink's mission is to provide users around the world with high-speed internet access. The individual satellites of this network orbit the planet at several orbital planes, approximately 550 kilometers above the surface. The fact that the Starlink satellites operate in low orbit has several benefits. The communication signal between the user and the satellite traverses a much shorter distance than if the satellites were in geostationary orbit, for instance, resulting in lower communication delays while requiring less transmitting power. Furthermore, satellites at the end of their lifespan are more easily deorbited into the atmosphere from low orbit. The first stage number B1062 was used for the 17th time. This is a respectable figure, yet it is not a record. SpaceX also has one first stage in its inventory that has been utilized 18 times. The landing site for the current mission was the Just Read the Instructions autonomous drone ship, located 618 kilometers from the launch site. This bright cluster of stars and dust is the spiral galaxy NGC 1385, located approximately 30 million light-years from Earth. The Hubble Space Telescope has previously captured this object, although in different wavelengths. In this image, the pinkish-red hues are more prominent due to the selection of filters employed. The prior image was largely characterized by a cool blue hue. This variation in coloration is not merely aesthetic, but also has scientific implications. Utilizing various numbers and types of filters to acquire data provides scientists with a more comprehensive understanding of the object. It can be perplexing that the same object can appear so dissimilar when captured through different filters. It is imperative to not misconstrue the term filter as any software employed to modify photographs for social media. Space telescopes utilize real tangible filters that only permit radiation of a particular wavelength. Consequently, astronomers are able to analyze very precise components of the electromagnetic spectrum. What are the practical implications of this? Certain physical processes in some elements emit light at precise wavelengths. It is due to filters that these wavelengths can be observed optimally and without interference. Thank you for your attention to today's episode of Spaceflight News. We are delighted in your interest in space news, and to ensure you do not miss future episodes, kindly consider subscribing to our channel. Additionally, you can find other interesting news on our profile on social network X, formerly known as Twitter. The link can be found in the video description.